In this last video, before we do some evaluations on derivative rules, I just want to look at some of the algebra you can use to clean these things up once you get not hard derivatives, but particularly large derivatives, and then some work with equations of tangents and normals. So, number one, we're given f of x equals x plus 2 to the exponent 4 times 2x minus 1 to the exponent 3. So this is power rule, product rule because we have multiplication, power rule because we have powers, and chain rule because even though we have exponents 4 and 3, we have things happening inside. The good news is you really don't have to go through the process of thinking of all that if you understand how to do the derivatives. So f prime at x is going to be, and this is where I'm going to do product rule, the derivative of the first. So I did chain rule. 4 came down, keep it the same to the exponent 3. Then I look inside, and the inside derivative is 1. So that's the derivative of the first times the second plus the first times the derivative of the second. So I kept the first the same, and now I'm going to apply chain and power rule again. So the 3 is going to come down, 2x minus 1. The 3 drops to 2, and now I look inside, and the inside derivative is 2. And I'm just going to clean this up a little bit. I'm not really going to do a lot of work in this case. I multiplied 4 times 1, which I really didn't need to do. And over here, I'm going to multiply 3 times 2 because they're both coefficients, and then keep my brackets. And now here is where we're going to be able to simplify this a little bit. We're going to common factor. If I look at my 4 and my 6, 2 is a common factor. If I look at x plus 2, I have 3 of them in this piece, 4 of them in that piece. So that means 3 of them are common. They both have, and I mean, when I say both, I mean these two terms, at least x plus 2 cubed. Then I'm going to do the same thing by looking at the second bracket. I have 2x minus 1 cubed and 2x minus 1 squared. So both terms have at least 2x minus 1 squared. So that's my common factor. Now I'm going to go back and compare it back to this. I had 4. I'm factoring out at 2, so I'm left with 2. I had x plus 2 cubed. I'm factoring out x plus 2 cubed, so it's all gone. I had 2x minus 1 cubed, but I'm factoring out 2x minus 1 squared. That means I still have a 2x minus 1 left. Then I have my addition in the middle. I had 6. I'm factoring out 2, so that gives me 3. I had 4 x plus 2s. I'm factoring out 3 of them, so I still have an x plus 2. And then I had 2, or squared, 2x minus 1, and that's what I'm taking out. So in front, everything is going to stay the same. And now I'm going to clean this bracket up a little bit. So I'm going to have 4x plus 3x is 7x. Negative 2 plus 6 is positive 4. So now I've been able to clean it up using common factoring. We can also apply this common factoring when we have a quotient. So I have 3x plus 1 to the 4 on top and 2x minus 3 to the 5, sorry if that's a little blurry, but it's a 5 on the bottom. So h prime at x is going to be the derivative of the top, which is 4, 3x plus 1 to the 3 times 3. 4 comes down, keep it the same, drop the exponent to 3, then look inside and grab the inside derivative, which is 3. So the derivative of the top times the bottom minus the top times the derivative of the bottom. So 5, keep it the same, drops to 4, then look inside, and the inside derivative is 2, all over the bottom, squared. Before I start to factor, I'm going to do a little bit of cleaning up. I'm going to multiply the 4 and the 3 together in this part to get 12. Then I have 3x plus 1 to the 3 and 2x minus 3 to the 5. Over here, I'm going to multiply the 5 and the 2 together to get 10. And I have 3x plus 1 to the 4 and 2x minus 3 also to the 4. And on the bottom, I'm going to end up with 2x minus 3 to the 10, because when you have exponents, two exponents, you multiply. Now I'm going to common factor the top. So 12 and 10, my common factor is 2. For the 3x plus 1 bracket, I have cubed into the exponent 4. So cubed or to the exponent 3 is common. For the second bracket, 2x minus 3, I have 5 and 4. So 4 are common. Now I'm going to build my inside of the bracket. So 12, factor out of 2 is 6. 3 brackets, factor all 3 out is gone. 5, factor out 4, I'm left with 1. Minus for the middle, 10, factor out of 2 is 5. 4 of these brackets, factor 3 of them out, I'm left with 1 of them. 4 of these brackets, factor all of them out, I'm done. So in this next step, before I simplify what's happening up here, I have something that I can work with. I have 2x minus 3 to the exponent 4 on top. So there would be 4 of these brackets and a repeated multiplication on top. I have 2x minus 3 to the 10 on the bottom. So there would be 10 brackets on the bottom. So I can actually cancel this, which is dividing, and subtract. If I have 10 on the bottom and 4 on the top, 10 subtract the 4 will leave me 6 on the bottom. So that changes my bottom to 2x minus 3 to the 6. I still have the 2 and the 3x plus 1 cubed in front, and now I'm going to clean up this bracket here. 6 times 2x is 12x, minus 15x is negative 3x. Negative 18 minus 5 is negative 23. So that would be my final simplified answer. Now the last thing I want to talk about is finding the equations of lines, but not just the tangent in this case, the idea of a normal. So if you have a curve, the tangent is the line that touches the curve at one place. So the green would be my tangent. A normal is a line that goes through the same point but is perpendicular. So the normal is perpendicular to the tangent. I know how perpendicular slopes work. If I know the slope of the tangent, the negative reciprocal is the slope of the normal. So I'm going to find, I need this point first, because remember we have looked at this. In order to find the equation of any line, whether it's a normal or a tangent, we use modified slope formula where I need the slope of the line and a point. I know x equals 2. I need to figure out what the y is. So g at 2 is 2 plus 1 squared, which is going to give me 9. So that's the first piece of information I have, because the normal and the tangent both go through that point. The only difference is the normal is perpendicular. Well, in order to find the slope of the normal, I'm going to find the slope of the tangent. The slope of the tangent comes from g prime.
Can I have your attention? Sorry for the interruption. Any students who have their immunization forms from A to K, or if you forgot your immunization forms, please go down to the library right away. Again, students from A to K, if you have your immunization forms, please bring them. If you did not bring your immunization forms, you can still go down to the library. A to K.
Sorry about that. So to find g prime, I do 2, keep the inside the same, drop the exponent to 1, then look inside. And I don't really need to because the inside derivative is 1 in this case, but I want you to be aware that I am going through that process. But we know the point is x equal to 2. So that's going to be 2 times 2 plus 1 times 1. So that is going to give me 6. So the slope of my tangent is 6 over 1. So that means my normal slope is negative 1 over 6, because perpendicular slopes are negative reciprocals of each other. I'm going to grab that negative 1 over 6 and put it in for my slope there. Now I'm going to cross multiply. I'm going to continue in a different color just so you can see that this isn't connected to that work at all. So I get 6y minus 54 equals negative x plus 2. Standard form always goes x, y, then a number equals 0, and you want the x to be positive, so I'm going to move everything over to the left-hand side. So I get x plus 6y minus 56 equals 0. And then that would be the equation of the normal. If I wanted the equation of the tangent, I simply just would have went 6 over 1. It's just a different slope, same point. So now there's no homework from the textbook. I am going to post a link to a document with extra practice with these strategies, and I'm also going to post the solutions so that you can check your work. It is expected that you simplify using the common factoring when you do your unit evaluations, be it the assignment or the test question, basically from here on in.